Now we're moving on to lesson 6.6, which is solving systems of linear inequalities. And the really nice thing about this is you're just adding a little bit to what you already learned in linear inequalities. Only difference here is you're going to be given two lines instead of one. You're going to graph both of your boundary lines on one plane. Make sure you watch your dashed or your solid lines. And then you're going to end up shading the area between the lines that's true for both inequalities. And you're going to do exactly what we did with linear inequalities, but you're going to have to try the points in both equations, and they're going to have to be true for both to be able to shade them. Copy this down, hit play when you're ready to continue. I'm going to go ahead and graph one line in red and one line in pink so you can see the difference. So we're going to start with the boundary line for y is greater than 2x minus 5. So our boundary line is going to be y equals 2x subtracting 5. This line happens to be in slope-intercept form, so you would want to graph it using slope-intercept form. B is negative 5, m is 2 over 1. The other line, 3x plus 4y is less than or equal to 12, is actually in standard form, intercepts, so you want to use intercepts to graph this. And I should have written it with an equals, sorry, equals 12. So we're going to go ahead and set up our t-chart with our intercepts, plug in 0 for x, and you can just look at that mentally. This becomes 0. I have a 4y equals 12, divide 12 by 4, and I get 3. That's the point in doing intercepts, is that you should be able to do it mentally by now. Plug in 0 for y, that's going to cancel. I have 3x equals 12, and 3 divided into 12 is 4. There's my 2 points. So I have the point 0, 3, which is going to be my y-intercept, and the point 4, 0, which is going to be my x-intercept. Go ahead and graph each of those. Make sure you're careful about what type of line you should have. So this line should be dashed. This line should be solid because it has an or equal to. And if you need to, write yourself those notes before you go to graph so you don't forget about them. Go ahead and graph those. I'm going to graph them on this, but I might block you a little bit. So I'm going to graph the first line, the dashed line in red. I'm going to start at negative 5, which is right here on my y-axis, and then I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, and this is my dashed line. Not the straightest line, but it gives you the idea. I would never pick a point that's really close to the edge of this boundary line at this point, because I could be off a little bit with my line and that could end up messing it up. And then I'm going to graph the other one in pink. This is my solid line, so I go over 0, up 3, and over 4, up 0, and I connect that. Solid because it was or equal to. There's my 2 boundary lines for these inequalities on one graph. Now, the way that you're going to find if you have a true solution or not. Notice when we were looking at just one inequality, we had either this side or this side. If we were looking at just this one, we would have this side or this side. What's going to happen now is we have 1, 2, 3, 4 spaces. You're almost always going to have 4 spaces there. And here's what's going to happen. One of these sections is not going to be true for either line. one of these sections is going to be true for both lines. And then the other two sections are each going to be true for one or the other. So just because it's true for one does not mean it's true for the other. I'm going to use the same rule that I used yesterday, which is I like to start with 0, 0 whenever I can. Now, if I plug in 0, 0 for the first line and it works, I need to try it in the second line. If it doesn't work, I just move on to this next section and I would find a point in here. So I might go over 4 down 2. So 4, negative 2 would be what I would plug in. And I would try that, and if it didn't work, then I would go maybe over 6 up 2, and I'd try 6, 2 for this section. And if that didn't work, then I would know it's this one. But just to make sure, I could go over 2 up 3 or 4 and try something in there. So you have to try all 4, and it has to be true for both. Let's go ahead and plug in 0, 0 and try it out. So we're going to use the point 0, 0, and we're going to try it in both. So first, let's try it in the 3x plus 4y. So 3 times 0 plus 4 times 0 is less than or equal to 12. This becomes 0 and this becomes 0. Is 0 less than or equal to 12? Yes. Okay, so because it's true for the first one, now I have to go try it in the second one. It has to be true for both. So my second one, 0 is greater than 2 times 0 subtracting 5. 0 is greater than negative 5 because that became a 0. This is also true. So because I got yes for both, when I plugged in 0, 0, that means that the point 0, 0 right there on my graph is the true section. This section right in there is my true section. So that would be all the area on the graph that I would shade. Remember, it has to work for both. If I was to plug a point in from here, it would be true for one of these two equations, but not for the other, for one of the two inequalities. And if I was to plug a point in there, it would be true for the other one, but not for both. And then if I was to plug in a point here, it would not be true for either of them. It's always going to be that way. This is my true side, this is my completely not true side. This one, everything here is going to work for that dashed line. This one, everything here is going to work for that solid line, but this is the overlapping part that works for both. And if you need more explanation on that, let me know tomorrow. Here's example 2. What they're going to do this time is they're actually going to give you a system of linear inequalities, and then they're going to ask you to write out the system instead of graphing it. And I didn't graph the shaded area yet, so I'm going to go ahead and graph what they gave me as shaded right now. A lot of our examples are using the point 0, 0. Notice 0, 0 is in my shaded area again. That's just, it's easier. It's not that it always happens, but it's easier. So it's part of the reason I use it in the examples, because it's faster to plug in. But don't expect it to always be that way. So if they were to give you this, you're going to have to go ahead and hit pause in a minute and copy that graph down. But what you're going to end up doing is you're going to find the equations that match each of the boundary lines, which you've done before. Once you have those, you're going to pick in any point from your shaded area, you plug it into each of the equations you came up with, and then you make the correct inequality sign for that, whether it's a greater than or equal to, less than or equal to. And remember, the or equal to is going to depend on the dashed versus solid. Go ahead and copy the top half here down. Hit pause, hit play when you're ready to copy the bottom. That's the rest of it. Once you're done, hit play and we'll go through the example. Alright, so what I'm going to go ahead and do is I am going to just highlight this one in pink, this boundary line. Okay, and this is going to be our first line that we're going to look at. I don't know if you can see that. So we're just going to look at the first one in pink. You have a couple options here. You can look at standard form because you notice there's an x and a y intercept, but you can also just go ahead and count out your slope. So if I was going to count out my slope, I would always look first. So first line, m equals, notice my slope goes down to go right, so it's going to be a negative slope. And then I count how many I would go down till right. So 1, 2, 3. So I'd go down 3 and then right 1, 2, 3, 4, 5. So m is negative 3/5. B, which is my y-intercept, starts at 3. And now I can write that equation, basically. So my equation is y equals negative 3/5 x plus 3. M and B plugged in. Now I'm going to look at the second line. Okay, this one is going to be our second line. Notice it's dashed. Same thing. I can start at m, or I can count out my m, my slope, up to right 2. And 2 over 2, if you need to write it in there, also means 1, doesn't it? Or 1 over 1. And if you notice, up 1, right 1, up 1, right 1, up 1, right 1, it follows that pattern also. Your B, your y-intercept, is negative 2. So your equation for this boundary line, y equals 1x subtracting 2. Now that you have your boundary lines written, you want to go ahead and find these as inequalities. So now, use a point from the shaded area. Notice 0, 0 is in our shaded area. So go ahead and use 0, 0. I'm going to put shaded area there because I don't want you always thinking you get to use 0, 0. It's something from the shaded area to find inequalities. Take your first boundary line and just write it. Y is something to negative 3/5 x plus 3. And then your second one, y is something to x minus 2. Okay, I took these two boundary lines and I rewrote them without an equal sign. Now we're going to use the point 0, 0, plug it into this to see what would make it true. So 0 is something, this would be a 0, right, to 3. Is 0 greater than 3 or is 0 less than 3? 0 is less than 3. So we know a less than is going to have to go here. Now you need to look, is it an or equal to or not? The first equation was a solid line. So because it's solid, it would be less than or equal to. And that's how you get that. Hit rewind and watch that again if you're confused about it. Now we're going to go to the next one. 0, because we're using the point 0, 0, is something to 0 minus 2, which is a negative 2. Is 0 greater than negative 2 or is 0 less than negative 2? Hopefully you all noticed it's greater than, so you'd put a greater than here, and now you go figure out if it's a solid or a dashed line. Because it was dashed, it's not or equal to. And there's your system of equations written from the given graph. You're going to come across some word problems in the linear inequalities and the systems of linear inequalities work. I'm going to post separate notes if you need help with those.